time, bless you. The exponential function is called exponential because the variable is the exponent. And the base, however, is restricted, either greater than 1 or between 0 and 1. Therefore, there will be two different situations for this function. F of x equals 2 to the x, and let's say f of x equals 1/2 to the x. As you already noticed, I'm sure, you realize that this is this function where the base is less than 1, like 0.5, and this is the other situation when the base is greater than 1, like 2. And we want to talk about the graph and see the graph of this function. See how it looks like. Because we have now a list of 6 functions, I think, that we know how to graph. This will be added to that list. Okay? So I have to find the domain first. Every time I'm asked to graph a function, I know that I have to start with the domain of that function. So the domain refers to x. It does not refer to the base, right? So the question is what x can be. And before you say anything, let's say, okay, can I raise 2 to the second power? Can I raise 2 to 0? What do I get? 1. 1. There is no number that you raise to 0 to get 0. There's no such thing. So can I raise this 2 to -3? It's 1/8. Sure, of course I can. So then what is the domain of this function? Right, it's a friendly function. -infinity to infinity. No restrictions. Friendly. Like polynomial functions. Like the cube root. So, nice function. Defined everywhere. Don't have to worry about anything. Good. Now, I start a chart. X, f of x for both. You already told me the domain. I'm going to put it in the chart. It's between -infinity and infinity, -infinity and infinity. And I am going to pick some values, some x values. I will pick -2, -1, 0, 1, and 2. You can say, that many? Yeah, to see the shape the first time, yes, I would pick that many. So -2, 0, 1. Ooh, I wanted to put -1. 0, 1, and 2. Okay, so please plug in -2 in the first function. We are talking about 2 to the x. Plug in -2 and tell me what you get. So I can write the answer up down here. Excellent. 2 raised to -2 is 1/2 raised to the second power. Let me write this time. 2 to -2 is 1/2 to the second power, which is 1/4. Is that clear for everyone? Okay, 1/4. Can anyone give us the y value when x is -1? Do you all agree with 1/2? Please plug in 0. 1. Please plug in 1. And please plug in 2, 4. Now, I am trying to establish where the function is going. I know x squared does this, right? It comes from positive infinity, it drops to 0, and then goes to positive infinity, correct? That's x squared. But I'm trying to establish what is happening here and what is happening here. So bear with me. I'm going this way first. 1/4, 1/2, 1, 2, 4, 8, 16, 32, 64, 128. Where am I going? By that we mean what is this?
Infinity.
Thank you. I'm going the other way now. Careful, please. 1, 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, 1/128, 1/1,000,000. It cannot be negative. 1 over a million cannot be negative. So where am I going?
0.
Yes. Let's graph this function. Please give me the first ordered pair you want me to plot. Excellent. -2, 1/4. Bear with me. I know you're going to say, but that's not 1/4. I will agree. But bear with me that I can plot 1/4. Okay, next ordered pair.
0.
Careful. You're right, but I want one in the middle.
Oh, sorry.
-1, 1/2. Next one. Excellent. And 2, 4. Here is my graph. It does not touch the x-axis. So this is 2 raised to x or just 2 to x. Right here, right now, I would like someone to give us the range so we can write it. Careful. The range is right here. Very good. Perfect. Is this function always increasing or not? So look at my hand. Is it always increasing? Yes. Function is always increasing. Is this function 1-to-1?
Yes.
If it is 1-to-1, then you will say it will always have, or it has what? If it's 1-to-1. It has. Excellent. Can I graph the inverse? Can anyone help me with a few ordered pairs to graph the inverse? I'm ready. Good, I'm ready. 1/4 -2. 1/4 -2. 1/2 -1. Careful. Yes, well, you said 1, 0. Yes, I'm sorry. I misheard. Sorry.
So 2.
Very good.
4,
2, 1. And 4. 1, 2, 3, 4, 2. What do we know about the graphs of f and f inverse? They are very good with respect to. We reverse them over what? From here, here, from here, here, from here, here, from here, here. Over y equals x. Please remember that. We wrote that as a note last time. Please remember, one more time, the graphs of f and f inverse are symmetric with respect to the line y equals x. Very good. Is this function increasing? Yes. If the function is increasing, its inverse will be increasing. And remember, this always happens for the base greater than 1. The function will always be increasing. Ready for the base less than 1? Good. I need to plug in x, replace x by -2. Please tell me what to write. Very good. Do you all agree with 4? Okay, let me show it here on the side. Y 1/2 raised to -2 is 4. In case you are wondering. Is anyone wondering? Yes. Okay, very good. So 1/2 raised to -2 is 1 over 1/2 raised to the second power, which is 1 over 1/4, which is 4. Is this okay? I expect a yes or a no or a maybe or yes? Okay. That's how we get 4. Now, when x is -1, what do we get? When x is 0, what do we get? When x is 1, what do we get? Wonderful. And finally, when x is 2, very good. Ready for the graph? Good. Please give me the first ordered pair you will tell me to plot. What can you say about this function? Is it decreasing or increasing on all its domain? Good. F is decreasing indeed on all its domain. Is it 1-to-1? By the horizontal line test, it's 1-to-1. Does it have an inverse? I would like you to help me plot the inverse, graph the inverse. For -2. 2, -1. 1, 0. 1/2, 1. 1/4, 2. The two graphs are symmetric with respect to, they must be symmetric with respect to, right here it has to pass to this point where they are both the same. Why? Because if, it's not. But if this point is 1, 1, when you reverse it, it's still 1, 1. So that has to belong to both functions. Since this function is decreasing, what can you say about its inverse? Decreasing as well. Yes, both decreasing. Good. So I would like to look on page 736 and look at a few word problems and equations. And I would like you to tell me what type of equation is this. I'm going to copy 21 on page 736. 3 to the x equals 27. We know several types of equations. We know linear, we know quadratic, we know absolute value, we know polynomial, we know, I think that's it. What type of equation is this? Say it again. Of course, because the variable is at the exponent level. It's an exponential equation. Absolutely. Good. So how will you address this? Okay, so let's discuss it. First of all, I see the left-hand side has base 3. So the left-hand side is 3 to the x. And I'm hoping that I can present the right-hand side, which is 27, with the same base. Is there any way I can change 27 into 3 raised to some power? Good. So now I do not simplify bases. I do not cross out bases. Please do not do that. This is what I think. Two numbers are equal. I'm told they're equal. And they have the same base. What has to happen to their exponents? They must be the same. So therefore, from here, the equation is solved. X must be 3. Of course, there are more sophisticated situations, like for example, and way more difficult than this, not the ones that we are going to look at in this class, though. I see the right-hand side base 2. I'm really hoping that the left-hand side can be presented with base 2 as well. If it can't, the problems can still be solved, but not in this class. You have to wait till the next one. 2 to the 5th. 2 to the 5th. So we replaced 32 by 2 to the 5th. Now the left-hand side is I copy the base. What happens to these exponents? Multiply. So please multiply, but you have to distribute. So the product will be 5, quantity 2x minus 3. Please tell me what to write as the power of 2.
10x minus 15.
Now I'm back to the previous situation. Here's the thought behind it. Two numbers are equal. I'm told so. They are equal. And they have the same base. What has to happen to their exponents? So therefore, from here I know that 10x minus 15 must equal 1. Power of 2 is 1. Now this is linear, no problem. I move 15, I divide by 10. So it's 16 over 10. And I simplify by 2, and I get 8/5. Now I would like to pick a couple of problems for you to work on. Like 33. Any questions on 25? Any questions on 25? Please, any questions on 25? Okay, let's look at 33. 27 raised to x plus 1 must equal 9. So let's work on this for 1 minute. If you need help, let me know, please. I'm putting in my attendance. Gee, no one is missing. Yay! Can anyone get us started? Can it?
Each of them will have the same base.
Yes.
So 9 will be 3 to the second, and 27 will be 3 to the third.
Do you all agree with 3 to the third raised to power x plus 1 and the right hand side 9 being 3 squared? Is it a yes? Perfect. It's not yet done. I have to copy the base and I have to remember what to do with these exponents. 3x plus 3 equals 3 squared. Now, here's again the thought behind it. Two numbers are equal because I'm told so. And they have the same base. What has to happen to their exponents? Right. So from here I know that,
3x plus 3.
which means 3x equals -1 or x equals -1/3. These are linear equations now that we know how to solve. It's up to you. Should we practice more? I'm more than happy, of course. Let's work on 35. 81 raised to x minus 1 equals 27 raised to 2x. Okay, 2 minutes. Let me know if you need help. Okay. Can anyone tell us how to rewrite the left-hand side? Do you all agree with 81 being 3 to the 4th? And 27 as being? Good. Now I copy the base. Do you all agree with 4x minus 4 as the power of the first side? Okay, left-hand side. And then copy 3. 6x. I don't want to see this. This is terrible. I don't want to see you do this. This is not what I'm doing. I'm not simplifying the bases from both sides. That will be terrible. The knowledge or the thought behind this is this. Two numbers are equal and they have the same base. What has to happen? Bless you. So then from here, I know that 4x minus 4 must equal 6x. Yes, I will move 6x and I will move 4. It doesn't matter what you do, we will get the same answer. Negative 2x equals 4, so x equals negative 2. Any questions?
This is as hard as well, right?
In this class, yes. Because exponential equations are way more sophisticated than this. But in this class, it will not get harder than this, no. Okay, should we do one more? Okay, let's look at 34. And that is 125 raised to x minus 2 equals 25. 1 minute, and then we'll look at word problems. We need more time? Done? Very good. The left-hand side, please. Do you all agree with 5 cubed instead of 125?
Yes.
And the right-hand side? Do you all agree with 5 squared instead of 25? I copy the base. What happens on the left? Because I have to distribute. 3x minus 6 equals 5 squared. Two numbers are equal. Their bases are the same. Therefore, from here, I conclude that it must be 3x minus 6 must equal 2, or 3x equals 8, or x equals 8/3. Do we get the idea behind solving exponential equations that have both sides that can be presented with the same base? For example, we're not going to do this, but there is a way of solving this as well. But we're not equipped yet with the knowledge to do this in this class. Okay? Good, so let's look at word problems. Do not ever be afraid of word problems in using exponential functions. They are very easy. Very easy. Especially in this course. Okay, I'm going to start with problem, let's say 46, caught my eye. The atmospheric pressure, P, in pascals, that's the measurement unit for pressure, on a weather balloon decreases with increasing height. The pressure measured in millimeters of mercury is related to the number of kilometers h above sea level by the function P, pressure of the number of kilometers above sea level, P function, pressure function of height, equals 760 multiplied by 2.7 raised to negative 0.145 and the variable h. So now the question is, first of all, I'm asking you what type of function is this? Of course, because the variable is at the exponent level, of course. Excellent. Good. So let's read the question now. It says, round to the nearest tenth of a Pascal. Find the atmospheric pressure at a height of 1 kilometer. Find the atmospheric pressure at the height of 1 kilometer. Exactly. H equals 1 kilometer. So then I have to find, so P of 1. I cannot do this by hand. We have to make the use of the graphing calculator. Sorry, I wasn't ready. Okay. So 760 multiplied by 2.7 power. I'm sorry, I have to put the product. 760 multiplied by 2.7 power now, in parentheses please, negative 0.145 times 1, which is 1. Times 1, which is negative 1.145. Okay, ready? Press enter. And the answer is 658.06 pascals. 658.6.06 pascals. Question number, part B. Find the atmospheric pressure at a height of 10 kilometers. So then I have to find P of 10. I go back to the graphing calculator. I recall what I had with second and entry, and I just multiply by 10 and close the parenthesis. So of course, as we go higher, the atmospheric pressure is lower. So 180.03 pascals. Questions? Problem 41. The equation y equals 140,242 multiplied by 1.083 raised to x. They say models the number of American college students who studied abroad each year from the year 2000 through the year 2009. In this equation, y is the number of American students. So y is number of students. And x represents the number of years after 2000. So x equals what for 2000? So how much is x for the year 2000? Yeah. Very good. Good. So then, I lost it. Where am I? Okay. Round answers to the nearest whole. Estimate part A. Estimate the number of American students studying abroad in 2004. So our first question is asking us to find how many students were studying abroad in the year 2004. What do I need to do? So I find y when x is? Very good. Do you all agree? So for this, x equals 4. So then y equals 140,242 multiplied by 1.083 raised to the 4th power. So I go back to the graphing calculator and I put in 140,242 multiplied by 1.083 raised to the power 4. So it appears that they were nearest whole. So 192,927 students studying abroad in 2004. Part B. Assuming this equation continues to be valid in the future, which we don't know, but assuming it is valid in the future, use the equation to predict the number of American students studying abroad in 2015. Bless you. In 2015, what do I have to put? Good. So then in that case, y, I go back to the graphing calculator and second an entry, and I just replace 4 by 15, close the parenthesis, and I click enter, and I get 463,772. 463,772 students studied abroad. One more application, and then I think we can move on. Any questions for me so far? Any questions? Easy enough? Okay, very good. The exponential function is really our friend. As I mentioned before, there are a lot of applications. Okay. We have a formula that will be given to you. So I'm not going to ask you to memorize this, but let's talk about the following formula. 1 plus r over n raised to n times t. This is A, P. I will explain what they mean. A, P, little r, lowercase n, and t. A stands for accumulated value. P stands for principal. R, little r, annual interest rate. T, little t, time in years. And lowercase n, number of times we compound the interest per year. Number of times interest is compounded per year. So the formula will be given to you, however, you have to know what these mean. So one more time, A is the accumulated value. P is the principal. Lowercase r, annual interest rate. Lowercase t, time in years. And lowercase n, the number of times we compound the interest per year. Now, let's look at problem 47 that uses this formula. Find the amount Erica owes at the end of 3 years. So what is that? From all the variables we see here, what is that? Very good, of course. If 6,000 is loaned to her, which variable is 6,000? P. It's what she takes out or what she deposits. Okay, at a rate of 8%. What variable is the rate of 8%, which has to be replaced by 0.08? Little r, very good. Compounded monthly. How much is n? How many months are in a year? 12. So we have t, which is 3. We have p, which is 6,000. We have r, which is 0.08. And we have n, which is 12. And all we have to do is what? 6,000 in parentheses, 1 plus 0.08 divided by 12. Everything raised to power n times t. How much is n times 3? 36. No one can do this by hand, ever, I don't think. that's ever possible. So let's go to 6,000. In parentheses, 1 plus 0.08 divided by 12, close the parenthesis, caret, which is the power, and in parentheses, 36. And press enter. So at the end of 3 years, if she borrows $6,000 today at 8% per year, compounded 12 times a year, she will have to return how much? $7,621.42. Number 50. Find the amount accrued if 500 is invested. So what variable is 500?
P.
Very good. And earns 7%, which is 0.07. What variable is 0.07? Perfect. Compounded monthly equals 12 for 4 years. What does 4 years mean? Good. So please calculate the amount that we will get if we deposit $500 today at 7% compounded monthly for 4 years. How much will we make? Do we have a number? So A is 0.0. Do we all agree that if we deposit $500 today at 7% compounded monthly, in exactly 4 years from now, we have a total of 661.03? Did you get another number? Because I didn't calculate it. Are we okay with this? Okay. I don't have it here, and I didn't bring my other calculator. But when you first get your mortgage, you can call me and I'll send you a formula, mortgage or you get a loan for a car or a loan for a ship or a boat. Then I will send you a formula in which you will be able to calculate the monthly payment way before the bank knows what the number is. And they have no idea what it is actually and what it does. They have a software and they punch in 2 numbers and they get the result. Okay? So every time I had to go and get a loan or something, how did you get that? Because I know what it does. So you will know too. So just let me know. Okay, moving on to 12.5. We do not cover everything in this class in this chapter. So let me see where I'm at with the time so I can... 39.